Hello. Okay, so welcome everyone. So today we will be starting the week two live session on electronic waste management issues and challenges. And I will start by introducing myself. I'm the TA allotted to this course, and my name is Rajarshi Bhar. Currently, I'm doing my PhD in the Department of Civil Engineering in IIT Kharagpur, and my supervisors are Professor Brajesh Kumar Duga and Professor Makaran Madhav Ghangrekar. So, like every other live session, today also we will be having around 15 questions to discuss. Also, the solutions, and as customary, most of them, I think all of them today are all theory-based questions. So you may expect that maybe 30 seconds to 15 seconds based on the type of question. We can pause after showing you the question, and then you can uh, choose your answers and share it either on the chat box, or you can also unmute yourself and uh, discuss any point with us, or if you have any doubt, any queries, or anything you would like to add, share your experiences, you can do that as well. And also, since all of the questions will be theoretical based, I am expecting that we can wrap them up within 30 to at max 45 minutes. And after that, we can, let's say after 10-15 minutes, we can also repeat the question again for the participants who will join in late. And then, if the time permits, we can go for some of the common methodologies that are used for recycling the different types of e-waste. We can go over it and see how things are being done at different places and what is the R&D scenario in this regard. So without further ado, we will start on with the live sessions questions. Okay, so I hope my screen is visible. Yes. So the first question for today is, which of the following e-waste estimation method is more frequently used? Also, please feel free to use the chat box, and also you can Google the answers, whatever suits you. So the most commonly used technique of e-waste estimation. This is directly from the lecture slides. Can you please share full screen? So full screen, if we go, let me see. I think it's better. I will rather increase the size of the question that is here. Wait, there is something wrong with the cursor. Yeah, I hope it is better. You can see the question clearly, and the answer is option B is one of the guesses. So, any other guesses? Most frequently used e-waste estimation method. So, if you want to take a look at the answer in this particular lecture slide, you will see that your input-output analysis is the one which is most frequently used to determine the amount of e-waste generated. So, that is why in this particular question, option C is the correct answer. And then moving on to the next question, the proper management of e-waste can provide us which are the following options. So this is very, very simple. So what can be the benefits of proper e-waste management? I think this is very simple, so that is why no need to wait for this. So all of the above is the right answer because if you manage it properly, obviously you will have social, economic, and environmental benefits. Social benefits in the sense because e-waste is being also in developing countries, a huge majority of the fraction of e-waste is being handled by the informal sector. So properly managing it and bringing them in the organized sector will have various benefits to them, apart from improving their working conditions, their health standards. It will be a huge support for them from the hygiene and economic point of view. Also, that is what leads to point B. And then finally, there will be an environmental benefit because including the informal sector into the formal one, obviously, we will see much more funds being allocated to handle various chemicals in a more environment friendly way so that less emissions are taking place, whether it is aerial emissions or emissions to water or soil, whatever. So that is why option D is the correct answer. Then in this particular question, you have to choose among the e-waste generated due to small household appliances, what is the major component of such waste? So this is one of the important questions of today. Option D, yes, that is true. Plastic is the major component of the e-waste. So if you look at this particular data, although the data is a bit old, you can also try on your own to find some latest data. But typically, if you look at small household appliances, plastic consists of almost 38% of the total mass of weight of waste. And if you look at other categories as well, in large household appliances, most of it is ferrous, around 43%. And then in consumer electronics and ICT, so there plastic is having a, not plastic, there also ferrous metal is having 36, followed by plastic. So this is leads to the next question out of this, which are the following e-waste estimation methods is the least explored one, and that too due to complexity and high uncertainty. So we have already gone through the most frequently used one and now the least frequently used method. Yes, option A is the correct answer. Just give me a moment. In the uh, in the meanwhile, what I will do is that I will share you the next question. You can think about it. And okay, so I can see that which state I think there is an option for Madhya Pradesh and West Bengal, the state with the lowest contributor to e-waste quantity in the country? Some options we have got A. West Bengal and B. Madhya Pradesh. So I will show you this figure, which will help you to get the answer. So this is an older data, so you can always refer to one more recent one. So if you try to look at it, you will find that West Bengal, Uttar Pradesh, these two places along with Delhi. So among these, you want to see which is the lowest quantum of e-waste generation. So you will see it coming from Madhya Pradesh, which is 8%, followed by Gujarat, Karnataka, Delhi. All of them are leading, giving 9% each, and then West Bengal and Uttar Pradesh are at 12%. Maharashtra is the largest source of e-waste as of the data of May 2030.
Rajarshi, you are on mute.
Okay, thank you. So in this particular one, the figure that I just showed you, it is quite evident that the lowest one as of the 2030 data is Madhya Pradesh. Then highest one is your Maharashtra. So that is why in this particular one, we have option B as the correct answer, because here you can see Madhya Pradesh is having the lowest e-waste generation. After that, this is the cadmium that is present in your mobile phone battery. So the question is, from one mobile phone battery, how much of the water can be polluted due to the cadmium which is present there? So this question was also there in the lecture slides. Yes, option C is the correct answer. 600 meter cube of water will be polluted due to the cadmium present in one mobile phone battery. Then, which of the following pollutant causes perillosis? Perillosis. Okay, so this is also quite, if someone wants to guess it, it will be very easy. So it is, as the name itself goes, berylicosis. So it is due to beryllium. Option E is the correct answer. You can see it here. That's the third row. I will increase the size so it's easier to read. So you see, third row, beryllium. This is carcinogenic, and the disease is also written here, chronic beryllium disease. Then after that, we have also arsenic, barium, some of the other major pollutants found in water bodies and other matrices. Now, among these four options, which one of these is or are radioactive? Yes, option C is the correct answer. And yes, like the slides, as you know, I have shared this information in the last class as well. So I have shared the Google link for accessing these slides with NPTEL. So I hope that if you put a message or email to them, you can get the answer. Okay. So option C is the correct answer, americium. Then, which of the following conclusions can be drawn from the economic assessment of e-waste? D is the correct answer. Thank you. Then, which of the following state is having lowest per capita e-waste generation in India? Bihar. Okay, this is the correct answer. And then here is the data as well. So highest per capita is coming from Delhi and lowest is coming from Bihar. Now, coming to the next question, globally, now all of the next questions will be true and false. Globally, only 15 to 20% of the e-waste is recycled, rest is dumped into developing countries. Whether this is true or false.
अच्छा अच्छा ओके एक काम करो 550 में तो हाँ 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 ठीक है तुमने अभी ऑन कर दिया क्या अच्छा ठीक है तो फिर डिनर के बाद ही आ जाना देर वुड बी बेटर
Option A, true. That is the correct answer.
तारा लगा लैब में अभी बोल रहे हैं कि सिंपल सा काम है कब से घूम रहा हूँ
So you can see it written here, globally only 15 to 20% of the e-waste is recycled, while the rest is dumped into the developing countries. Now the informal sector accounts for 5% of the e-waste recycling, and the 95% of the e-waste reaches the authorized recyclers. Whether this is true or false. So the correct answer is here false. That is option B. Thank you for the answer. Then electronic waste varies considerably with its age, origin, and manufacturer. Again, a very basic question. So here, of course, this is true because based on the place, time, and manufacturer, this can vary. So that is why it is true. Then if the CRT is crushed and burned, it does not emit toxic fumes into the air. So CRT are cathode ray tubes. So now this will be interesting whether this is true or false. If cathode ray tubes are crushed and burned, it does not emit toxic fumes into the air. This is the statement. Yes, option B is correct. This statement is false because various toxic fumes are emitted. Then e-waste should be considered as resource and requires uses in an efficient and sustainable way. So of course this is true. So these were the 15 questions that we had today. Now we will take a quick 5 minutes break and then go over these questions quickly once more, and after that switch out to some uh, research articles or maybe some of the recycling techniques of e-waste. Okay, so sorry for the delay. So any doubt in today's questions? So I will quickly go through these again. If you have any doubts or any points, please feel free to unmute yourself and share that with us, or you can also use the chat box. Okay, so which of the following e-waste estimation method is more frequently used? It is input-output analysis. That is option C. After that, proper management of e-waste can provide us social benefit, economic benefit, and environmental benefit. Very common. That is why all of the above is the correct answer. Then, among the e-waste generated due to small household appliances, the major waste component is your plastic. So, plastic is the major waste component in the small household appliances. After that, out of the following e-waste estimation methods, which one is the least explored due to the complexity and high uncertainty in the long-term patterns? So, it is the your factor models. After that, which of the following state in India is the lowest contributor to e-waste quantify in e-waste quantity in the country? So it is Madhya Pradesh. Give me a moment. Then cadmium from one mobile phone battery is enough to pollute how much volume of water? It is 600 meter cubes. And then which of the following pollutant causes causes? So it is beryllium. Then which one is the radioactive one? So it is americium. Then, which of the following conclusions can be drawn from the economic assessment of e-waste? So, large portions of the of precious and special metals are lost due to inefficient recycling process. True. Recovery of these materials presents significant economic opportunity. That is also true because there are different, very successful, very high recovery rate options are there, but the cost is too much for them. That is why economics is important, and then reduces the environmental impact due to mining of virgin materials. That is also true sometimes. Which of the following is the lowest per capita e-waste generating state? It is Bihar. Then true and false. So it says that 15 to 20% of the e-waste is recycled, rest is dumped in developing countries. That is true. Then informal sector accounts for 5% of the e-waste recycling and 95 to authorized. So this is false. Then electronic waste varies considerably based on its origin, age, and manufacturer. True. If the cathode ray tubes is crushed and burnt, it does not emit toxic fumes into the air. This is false. And e-waste should be considered as resource and requires uses in efficient and sustainable way. Of course, this is true. So please let me know if there are any doubts. Otherwise, I will prefer going through some articles. I need that. नहीं नहीं सारी एनालिसिस करनी है ये ले लो
ये थोड़ा कंफर्म करके दे दो कि कितना है, अगर आपका नहीं है।
So this is one article. on the exposure to hazardous substances and cathode ray tubes recycling sites in France. So since we had a question on the crushing and burning of cathode ray tubes, whether it emits toxic fumes or not, and so if you want to just look at the basic findings of this study, it says that provide class notes 1 to 2 information. Yes, I have taken a note and I have told the professor as well that 1 to 2 slide information. Yes, because in the
Sir,
last
your
class,
mic has been turned off. Please turn it on.
okay. So I saw that this 1 to 2 slides, there is a comment here. So in the previous class as well, I got a similar observation. So I have informed the professor that whether it will be possible to provide you the notes so that each page has 2 slides. It is easier to read. So I will give him a reminder once. And apart from the questions, uh, so this is regarding one of the questions that we had in true and false today that was regarding cathode ray tube recycling. So this is one such paper of 2015. So what the major findings were that chemical risks in this paper was assessed in 9 cathode ray tube screens recycling facilities. So the data is based on actual recycling facilities and not from coming lab scale studies. And also the main hazardous agents were the dust, the particulates that mainly consisted of lead, cadmium, barium, and yttrium. After that, exposure and pollutant levels are described for different operational processes, and then all the operational processes are concerned by significant. So this particular point it tries to say is that under all the conditions, the concentration of these pollutants were quite significant and requires immediate action. That is why in the final point it says that recommendations were made to reduce the chemical risk. And this is some of the maximum levels of these uh, particulates which the workers were experiencing of barium, cadmium, yttrium, and lead. So you can see that, for example, 8.8 milligram of barium was there per meter cube of air that was sampled, and similarly different other elements as well. So let me see if we can get some good figures here. Okay. So this particular figure is on the composition of the panel glass, cone glass, and Frit glass, which is there in the legends, obtained after analysis under this microscopy and EDS. So you see that once these kind of glass, they were or components were analyzed, this purplish color one, I think this bluish one is for panel glass, red is for funnel glass, and then there are other two components as well. Frit is there. If you see like silicon dioxide or silica is one major component, lead oxide is again one major component. After that, barium oxide is there, mostly coming from panel glass. And then few of the other elements are also there in their oxide forms. So this was what originally is present there. After that, let me see. So you see, then this cathode ray tubes, this is a figure that shows that the particle concentration in particles per meter cube versus time during dismantling. So if you see that as dismantling took place and with the passage of time, and this time is in the form of minutes, I guess 15, 12, 14, like that. And this is the particle per meter cube. So you see the number of particles, it is quite high in this particular as the time increased. So initially, most of them in the ambient air were this 100 instance around 10 crore particles below this range. And as the time increased, you can see that some of the particle concentration, they were even higher, almost more than double of that. So let's see if we have something else as well. E-waste recycling. So this is a much more recent article on potential and current practices of recycling waste printed circuit boards through pyrometallurgy. So if you just Google the word pyrometallurgy, pyro means you can understand that this is heat, and basically pyrometallurgy is the process that uses heat to extract metals from ores, concentrates, and urban wastes. So easy to know what pyrometallurgy is, and it is one of the commonly used your recycling techniques. Apart from that, there is another technique called hydrometallurgy. So if you want to look, so in hydrometallurgy, it uses aqueous solutions to extract metals, ores, concentrates, and other materials. So one example can be, we know that metals, they dissolve in acid. So people, if they use strong acid solutions, they dissolve the metal in the acid first and then they try to precipitate it. So those kind of stuff can come under hydrometallurgy. So if we just want to focus on it and mainly look into the flow sheet of the overall pre-treatment steps in the recycling of metals from these waste printed circuit boards. The abbreviation is WB PCBs in this paper. So very common. First thing is it is disassembled so that you can separate the circuit board from the bigger equipment. Then it is thermally treated so that the board itself, its hardness is reduced, and then the size reduction is done through sorting. And after that, to separate metallic fractions of the boards for recovery, this is again sorting and updating. So size, so first thing is disassembling, then thermal treatment, then size reduction, and after that sorting. So now if you want to see the techniques applicable in physical upgrading of waste printed circuit boards. So if you need to separate it with respect to shape and size, then you use screens. Screens are basically like the chutney used for teas for while separating the tea leaves. That is why they used vibratory rotary shakers, sieves of different kinds, and can separate the component to coarse, medium, and fine materials. After that, for example, if you have some iron, nickel, so those magnetic material, so you can fix a magnet, and that can help you separate the magnetic components as well. Then electrostatic properties. So if there are eddy current separation and then some other techniques are there through which you can separate conductive and non-conductive materials. Also density wise you can separate. One of the very common example is if the waste is passing by, you can flow some air jets from below. So the lighter material, they will flow up and the heavier ones will flow down. So in that sense, you can separate the dense and light materials. And then surface properties, froth flotation. So this can be, for example, if you are working somewhere and something is having a property to form froth and floats on the top of the surface, so you can just skim it off. Okay. So now if you want to majorly look at the elemental metallics that make the waste printed circuit boards. So let's try to see which one is more. If you see it weight percentage wise, and the data given here is for aluminum, copper, lead, nickel, tin. Some of the data is in ppm as well. Okay, so this data, it is a bit difficult to understand which is in percentage and which is in ppm, so we will ignore it for now. See if we have something interesting. So now here you can see that it is a much more elaborate flow sheet. So if there is a waste printed circuit board, after disassembling, the pre-treatment incineration and bromium fixation is done. So molten salt is either used or pyrolysis is done, and the gases emitted from this process are carbon dioxide, carbon monoxide, and some uh, organic oils are also liberated, which contains phenols. So phenols, as we know, these are your aromatic compounds, and if you're handled properly, they have good calorific value and can be used as some sort of fuel. While these gases consist of carbon dioxide, if they are released untreated, they can contribute to your global warming potential. So that is why, while treating this, it is important to also take care of these emissions that are taking place from the system. And some of the ceramics are produced, silica, calcium oxide, that also have their use in different places. So once it passes through these techniques, after that you have size reduction, and in there certain flux. That means some of the metal, since it is a hot process, pyrometallurgy, so some flux or molten slag kind of stuff, it can also float on the surface. So that is one thing, and through which it can be removed. Then smelting and converting is also there. Then copper blisters are formed in between. After that, electro refining is done, where most of the major output is your copper. And then in anode, a slag is formed at the bottom of the anode, which mostly consists of calcium oxide, silica, alumina, and your iron oxide. After that, precious metals can also be recovered from it. So it is a very elaborate process, and you can spend a whole lot of time to look into how these things are taking place, what is the chemistry behind it, and what can be some of the major health concerns. So if I need to see major, okay, so this is a good example, a much more industrial scale unit. Let's see where the, so you see that this is the input area. Let's examine. On this right side, you have got the input where you feed in your electronic waste, e-waste. Once inserted, it passes on through some conveyor belts, goes into different units. And then in order to deal with the atmospheric emissions, you see that here is an electrostatic precipitator. So what this electrostatic precipitator does is that it removes your particulate matter by uh, passing them through a charge field in a manner that they develop a certain charge, those particles. And then while they pass through a certain area, they have got oppositely charged electrodes there, which attract that particles and they stick there. So in that way, electrostatic precipitators are used. They have got very good efficiency in removing particulate matter, but at the same time, they are costly. That is why whenever such a system is there, first what we do is that we pass the particles through a gravity separation. So what happens under gravity separation? The particles which can be easily settled due to gravity, those are first taken care of. And once a significant fraction is removed, then the remaining particles can be placed through electrostatic precipitators so that you have to exert less energy for treating the gaseous emission. Other than that, there are different other treatment units like bag dust collectors. So these are kind of your fabric filters, or you can consider them like big bags through which the gases pass through and the dust is collected there. So you can think of it like big filters. And after that, let's see what is B. So B is the e-waste fractions of various sizes. So after passing through all of these, so you can see that the size of the e-waste can be ranging from 1 mm to there are some 1 centimeter sizes as well of different materials, and then something that is below 1 mm as well. Okay, so now some of the opportunities and constraints in developing sustainable e-waste management system. So the opportunity lies in the fact that there are various precious metals there like silver, gold, palladium, stuff like that. But the complexity is due to the high volume, and if there would have been only one or two metals in the e-waste, it would be easy to separate. But if you have a huge or complex cocktail of elements in the e-waste, it is always very, very difficult to separate a single component out of it. And even if you are successful, it will cost you a lot. So that is why the complexity of e-waste is an issue. And then e-waste disposal with the household waste pollutes the environmental via leaching of e-waste toxicants into soil and water. So what they mean to say is that if the e-waste collection system is not at place, so and you dispose of the e-waste with the household municipal waste, then what happens? There's a chance that when that waste is dumped somewhere, then there is some water source, maybe rain. So during that activity, the water that leaches down through the dump of waste due to certain properties and activities going on, it often has a acidic nature. And due to that acidic nature, once it passes through the e-waste or over the e-waste, some certain fraction of metals, they get dissolved in that leaching fluid and can then go on to contaminate soil and water. And that acidic nature that develops in the water that passes through, which is known as leachate, it is due to the various anaerobic microbial activities that are taking place there, which develops various volatile fatty acids or organic acids, which makes the probability of dissolution of these metals much more high. And that also increases the risk of leaching of these metals to groundwater, soil, and sometimes even air as well if there is something going on uh, about incineration. After that, the opportunity can be obvious, creating additional jobs to support the economy. But as you can see around yourself, there's the lack of environmental awareness, knowledge on this e-waste collection and its potential. That is one issue. And then average grade of metal in various electronic items is better than ores excavated from mines. And then it says that in this particular point, that informal sector of e-waste recycling, it has lower efficiency and has got higher environmental costs. That means that the efficiency of e-waste recycling is low, and even if that certain fraction of it is getting recycled, it has got a huge environmental footprint. So like that, there are several other points here, which are more or less, if you try to go through these, that will appear to be quite common and evident. Let's see if we have anything else here. No, I think nothing else. So what I will do is that I will share the link of this particular paper with you. Copy link, paste it. Okay, fine. So I hope this was helpful. So if you have any doubt or any points to add, please feel free to share that with us. Otherwise, we can wait for some time and then call it a day. So I can understand that these sessions will appear a bit boring most of the time because we have got only 15 questions and then 2 hours is allocated for this. So mostly due to the theoretical nature of these questions, they can be covered in around 30 minutes. So remaining time, I try to go over various articles that I can find interesting and share them with you. I can see a question. Can you discuss week 1 and 2 assignments? No, like let me know when the dates, submission dates are over, and then after that, if you have any issues, so that can be resolved, but not before the submission dates. After that, if you have any doubts regarding the assignments, you can always share that with us. I'm also sharing with you a link of the e-waste handling rules that came out in 2022. So if you want, you can go over there. Certification exam questions only MCQ type. Yes, mostly they will be MCQs. Some 12 faults will be there, and maybe sometimes questions like MCQ, but you might have more than one correct answer. So if there is any problem equation, sorry, question that is given in the assignment, you can wait till the assignment submission date is over. Once that is done, then you can share that with us and we can see what kind of stuff it contains. Okay, so if you have any other questions, doubts, queries, please let me know in the chat box. Otherwise, we can call it a day. I will be here. So in case you still have anything to inquire about, you can use the chat box. Otherwise, it is not mandatory to attend the 2-hour live session for the entirety of the duration. In case if something is there, you can always take leave anytime you want. So thank you for that, and let me know if you have any doubts in the chat.